Today's problem is called bulbs. This problem lives on interview bit, so you can pause the video at this point, go over to interview bit, try to solve it, and then come back and we'll walk through it. Difficulty level for this is easy. So actually we're working through something that they make available on interview bit, and that is a 12-week interview preparation kit. We're on week 4. Almost every question so far has been easy. Now, I did want to say that not every easy problem is created equal. There's a range of problems. I think, there's only a limited number of categories here. I think interview bit does have a very easy category, but then after that they probably have easy, medium, hard. Not every easy problem is created equal. So anyway, I try to indicate when we do the problems whether a problem is really easy, or whether it's on the harder side of easy. This one I think it requires a little bit of insight to get it, but let's go on and take a look at it. Problem description is that N light bulbs are connected by a wire. Each bulb has a switch associated with it. However, due to faulty wiring, a switch also changes the state of all the bulbs to the right of the current bulb, meaning if they're on, the switch turns them off. If they're off, the switch turns them on. Given an initial state of all bulbs, find the minimum number of switches you have to press to turn on all the bulbs. You can press the same switch multiple times. That doesn't sound like a good idea, but you can do it. Note, 0 represents the bulb is off, and 1 represents the bulb is on. Okay, problem constraints. All right. It looks like scientific notation. I never see that in programming challenges. 5e5. Usually they would just write 5 times 10 to the 5th. So n, number of bulbs, can be between 0 and 500,000. Okay. We should take a look at this and make sure that it works with 0, because 0 is kind of an edge case, all right? But they're telling us that we could get a list, an empty list as input, all right? Well, what would happen? So we've got 2 variables that we need to keep track of. I mean, essentially they're the same variable. It's just that state is like count mod 2. But we start them at 0, and then we do this loop. I starts at 0, and as long as I is less than the size of the list, but the size of the list is 0. So we're not going to go through this loop at all. We just drop through the loop and return count. Now count was initialized as 0, so we'll return 0. So for edge case, n equals 0, it works. Input format. First and only argument is an integer array or list, in this case, of size n. Output format, an integer representing the minimum number of switches required. Okay. Well, let's look at this example. I think it will make more sense as we walk through the code, but okay. So let's use this example, 0, 1, 0, 1. Okay? And we want to make use of a couple of observations. One is that we want to move through this array or list from left to right, because you push a switch and it affects everything to the right. Okay? So by moving left to right, we make sure that whatever we have already processed will not be affected by any future processing. Once we're done with a bulb and we move to the next one, it's going to stay the way it is. And the other observation is that obviously, if it's going to stay the way it is, we want it to be on. So it's just a process of going through the list and turning every bulb on one at a time. The challenge there is that you also have to keep track of, as I'm turning on these bulbs or as I'm pushing these switches, how am I affecting other bulbs further to the right? Okay, so let's look at the example. 0101. Okay, so the first one, index 0 or switch 0. Why can't I turn that off? Switch 0. That is currently off. So we got to turn it on. So we press switch 0. Now that actually flips all the bulbs. So instead of 0101, we now have 1010. Okay, we're done with index 0, and we'll move to index 1, which is now 0. And we got to turn that on. So we push switch 1, and the list changes to 1101. Now we're going to go to index 2. It's off. So we got to push switch 2 and turn it on. That changes also the last element from on to off. That is now off. And so we have to press switch 3. And that turns all the bulbs on. So that's 4 times. All right. Well, one way to do this, not a good way, but is what they're doing here, which is to maintain the current state right in the list. So that is, when we get to index 0 and we see that we need to turn it on, we also go ahead and update every bulb to the right. Now, because we can have up to 500,000 bulbs, that's a pretty bad idea. You know, that every time we push a switch, we have to update hundreds of thousands of bulbs. So we are instead going to maintain the state just as a single variable. And that variable will be the count. We need to maintain the count because that's our answer. But the state is going to be the count mod 2. So it's either going to be 0 or 1. Now, if it's 0, that means that we've pressed an even number of switches, and if it's 1, that means that we pushed an odd number of switches. So let's try this out. Let me get a pen here. Okay, yeah, that should work. All right, state is 0, count is 0, I is initially 0. So we're going to check, is the state equal to the element of A at index I? Okay, so I is 0. A at 0 is 0. So state does equal, these two things are equal. They're both 0. What does that mean? That means that the element at I was initially 0, and the state is telling us either that we haven't flipped any switches or we've pushed an even number of switches, in which case the bulb would just be returned to its initial state. So if the state is 0 and the bulb is 0, then we've got to push that switch. So count, well, increment count becomes 1. Oops, I don't want to put it there. Put it up here. Count is now 1. Okay, and state, we flip the state. So state equals 1 minus the current state, which is 0. So state becomes 1. Let's go to the next element of the array. State is 1. A at index 1 is 1. So 1 equals 1. What that means is this bulb was initially on, but we have pushed an odd number of switches. So if the bulb was the bulb is no longer in its initial state. So if state is 1 and the bulb at index I is 1. By the time we get to it, it's not going to be on anymore. It's going to be off. And so we're going to have to push that switch, and then count would be incremented, and it will become 2. And we'll flip the state. 1 minus 1. State is now 0. All right. We'll go over here. I is 2. And this is just a repeat of the first two elements. State is 0. A at index 2 is also 0. That means we have to increment the count and flip the state. Okay, increment the count, flip the state. And finally, we go to index 3. State is 1. A at index 3 is 1. That means we have to increment the count. 2, 3, 3, 4. Flip the state. And we're done. Return the count, which is 4. Okay. Let's try and run this. Let me turn those off. All right, so I guess you could call that a greedy algorithm in the sense that we're just processing all the bulbs from left to right and turning each of them on. Now we have to do some state maintenance in order to be able to do that, to be able to tell from the initial on-off status of the bulb and current state what is the current on-off status of the bulb. And we just go through and we turn them all on. So that's it. Thanks for watching. If you found this helpful, hit like, subscribe, and check out the playlist on screen. There are a number of other videos on there that may help you improve your interview skills. Also, in the video description and the pinned comment, there's a link to a free coding interview patterns PDF. It includes greedy algorithms. And if you're in the interview loop, I think it'll be a big help to you. It's free. You can download it immediately. So that's it, and we'll see you next time.